Hello everybody, welcome to my YouTube channel. Today we are going to talk about the project, a recent project which I have published, Nepali image paragraph captioning. So let's dive into our project. So this is one of the first of a kind project that has been done in this field. Let's talk about the project. So we have implemented our project using transformer architecture. So why transformer architecture? Why we have used this architecture? To know about that, we first need to know some of the limitations of RNN and LSTM. Firstly, RNN could not provide parallelizations, and it can provide no support for long-term memory. And coming back to transformer, we have used encoder-decoder architecture, as seen in the figure. In encoder architecture, the feature extraction part of the image is done, and in decoder segment, we actually generate the captions. So before talking about the actual implementations or each of the layer, let's understand how a single head attentions work. Learning self-head attention, basically it has three parameters: query, q, key, k, value, b. So when the positional encoding obtained from the text or the image is passed to a linear layer, then the q matrix is obtained, and similarly the k and v matrix are obtained. So then next step is obviously about attention weighting. We have to find what is the attention weight, which part of the text or image we need to focus on. So this is actually about attention weighting. Now first we use similarity matching matrix, like q times k transfer is just like cosine similarity, and then we scale it, and after applying the softmax layer, the weight is obtained, that is the attention weight. We can see in the figure that he tossed the tennis ball to Sob. So the more the attention weight, the more the two words are related. Here ball and tennis seems to be more related, like Sob and he are less related. In this way, like a single head attentions know which part of the text to focus more on and which to give more attention. And then after attention weighting, this is the slide that I have already talked about. It's just using the similarity matrix. So and then after applying the having the attention weighting matrix, we need to extract the features. So how do we extract the features? We apply the matrix to the value, and then the output is obtained. That output is the features or the part that we need to focus more on. So now let's go back to our architecture. The part on the left hand side is encoder segment, and in the right side is decoder segment. For extracting the feature vector, we have used Inception version 3. It can recognize lots of objects present in the image, as it was trained on ImageNet dataset, and the extracted feature vector is passed to the linear layer before having a positional encoding, and from there the positional encoding is obtained. We will talk about the coding segment later. So I talk about single head attention earlier. In the same way, the multi-head attentions works, like it attends to more features, like more context. When for example, when the ball and tennis are related, and it is relation to space, its surrounding can be found with multi-head attention. Then we passed it to normalization layer. It is basically used to in training process to avoid gradient descent, vanishing gradient descent problem. After that, it is feed forward layer to extract more features, more dense representation. And similarly, in case of our token, the features are passed multi-head attention to have certain weighting among the captions, and then passed to normalization layer for uh, removing vanishing gradient. Then the multi-head attentions, next layer of multi-head attention has input from both the image extracted features and the text. From there, it is passed to feed forward layer, and the softmax layer is actually does decoding segment. So how this learning captions or features occurs during training process. During training process, in the second multi-head attention, the back propagation actually occurs. So here the decoder segment predict the next caption based on the previous caption and the input features. Whenever there is error or loss with the original captions, then it back propagate, and the whole weighting matrix of the encoder segment is also changed. So in this way it learns from the image of captions, and it generates the sentence. So that's it. That's the theoretical understanding of our model.